Good evening, guys. Today, what we are going to see is important theorems for class 10th CBSE board part 2. And let's go. Let us see what's the first theorem is. First theorem is Pythagoras theorem. Let us see the statement. It's in chapter Triangles, theorem 6.8, and the statement goes like this. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is, the statement says, if we consider a right angle triangle, the square of the hypotenuse, that is the square of the longest side, will be equal to the sum of the squares of the other two sides. That is, the sides other than the hypotenuse. Squares of those would be equal to the square of the hypotenuse. Let's see how can we prove this theorem. Okay. In given we can write that there is a right angle triangle given, ABC given, right angle that B. Okay. In this diagram it is not given, so we shall mention that too. And we need to prove that AC square is equal to AB square plus BC square. That's what is given in the statement, guys. Right now, because AC is the longest side of the triangle. If we see the figure, we can absolutely get to it. And AB is the AB and BC are the other two sides. So we should prove that AC square will be equal to AB square plus BC square. Now the construction part is nothing but we are drawing a line BD, that is the dotted line which is the construction over here. BD perpendicular to AC, the whole hypotenuse, the longest side of the triangle. Okay, this is the construction part. Now we can say that triangle ADB would be similar to triangle ABC. It's given over here that it is by theorem 6.7, that it 6.7 just states a similarity criterion. Guys, if two triangles have two same angles, corresponding angles, then they would be similar. So that's what theorem 6.7 says, if you guys just go through it. And if two triangles are similar, we can say that their sides would be proportional. So we can write that AD by AB would be equal to AB by AC. From this, if we just cross multiply, AD into AC would be AB into AB. That means it would be equal to AD into AC would be equal to AB square, which we can consider as equation 1. Now again from A similarity, that is angle similarity, we can say that triangle BDC is also similar to triangle ABC because both have a right angles. And from that we can also say, since both the triangles, that is triangle ABC and triangle BDC are similar, we can say that their sides would be also proportional. From that we can say CD by BC would be equal to BC by AC. From this we can cross multiply and get CD into AC would be equal to BC square. Now we know that we should prove that AB square plus BC square should be equal to AC square. We already got two equations. From this I think almost we are done. Let's see. Yeah, see, we should add first equation and second equation to get AC square. So if we want to calculate that, see, from first equation we can write AD into AC plus from second equation we can write CD into AC would be equal to AB square plus BC square. That's what given over here. That is AD into AC plus CD into AC would be equal to AB square plus BC square. Or we can write, since AC is common on both the things, in both the multiplications we can take it out as common and multiply as AC into AD plus CD would be equal to AB square plus BC square. We know that AD plus CD is nothing but AC again. So it would be AC into AC is equal to AB square plus BC square, which is nothing but AC square is equal to AB square plus BC square. That's all. Pythagoras theorem is proved. We have proved that AC square is equal to AB square plus BC square, which is hypotenuse square is equal to the sum of square of other two sides. Simple. That's the proof. But guys, be careful with the diagram which you draw. The diagram which you draw will matter again. Now, let's see the converse of Pythagorean. Yeah. See, I have mentioned already. Converse of Pythagoras theorem. Okay, this theorem is 6.9. In Pythagoras theorem, we have told that if in a right triangle, if hypotenuse square is equal to sum of square of other two sides, then its converse should also be true. The statement is given as in a triangle, if square of one side is equal to the sum of the square of other two sides, then the angle opposite the first side is a right angle. Okay. Now we should prove that it is a right angle triangle over here. If the triangle has sides, hypotenuse square is equal to the sum of square of other two sides. Okay. Yeah, we are given with a triangle ABC in which AC square is equal to AB square plus BC square. Now we should prove that angle B is equal to 90 degree according to this given diagram. Now what we are going to do is, we already have a triangle ABC. Now we are going to construct a similar triangle PQR, considering Q is right angle such that PQ is equal to AB and QR is equal to BC as given in the figure, guys. Now from triangle PQR we can write that PR square is equal to PQ square plus QR square. We can write this equation using Pythagoras theorem as Q is equal to 90 degree, or we can also write PR square is equal to AB square plus BC square, because we are already by construction we are uh, just assuming that triangle ABC and PQR are similar and equal also. So from by construction we can also write PR square is equal to AB square plus BC square. Now we are considering this equation as the first equation. But we know that it's already given that AC square is equal to AB square plus BC square. So from this we can conclude, that is from given part and from the construction part, we can conclude that AC is equal to PR, and considering this equation as equation number 3. Now comparing both the triangles, that is triangle ABC and triangle PQR. By constructions, AB would be equal to PQ, BC would be equal to QR, and AC is equal to PR, as we have proved in equation 3 by constructions and givens. Okay, now from this we can say that triangle ABC would be congruent to triangle PQR, and therefore by corresponding parts of corresponding triangles from that technique or method, we can conclude that angle B would be equal to angle Q. But we know that by construction angle Q is equal to 90 degree. So angle B should also be equal to 90 degree. So converse of the Pythagoras theorem is also proved. That's all, guys. See you guys with some other interesting and useful video. I hope it would be useful to you guys, and please suggest me if you want videos, engaging videos on any other important topics It can be maths or science also. Please suggest me, guys, so that I can help you out. Thank you, guys. Please do like, subscribe for more such updates. Thank you, guys.